Welcome and thank you for joining us today for Managing Tomorrow's Networks, the impacts of SDN and network virtualization on network management. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speaker is Shamus McGillicuddy, Senior Analyst at Enterprise Management Associates. Shamus has 10 years of experience in the IT industry, primarily as a journalist covering the network infrastructure market. At EMA, he's the Senior Analyst for Network Management Practice. Prior to joining EMA, Shamus was the News Director for Tech Target's networking publications. And before I hand things over to Shamus, I wanted today's audience to know that Shamus will be taking a couple of questions at the conclusion of today's event, so do feel free to log any questions you may have anytime throughout the course of the presentation. Also, today's event is being recorded, and you will receive a follow-up email from EMA tomorrow that will include the on-demand playback as well as a link if you're interested in the full report. And now I'd like to go ahead and turn things over to our featured speaker, Shamus McGillicuddy. Shamus?
Thank you, Raleigh. Thanks for the introduction, and thank you to everyone who's attending today's webinar. As you can see on the slide, this is about managing tomorrow's networks, or maybe for some of you it's today's networks. We are going to be looking at some highlights from my new research report on the impacts of software-defined networks and network virtualization on network management tools and practices. Before I get into the nitty-gritty, let's just recognize our sponsors for this research. These 9 companies contributed to supporting this project. We got CA Technologies, CloudGenix, IBM, LiveAction, Packet Design, Pika 8, Pluribus Networks, Viavi, and Viptela. So thank you to those folks for their generosity and their help. On the agenda today, we're going to talk about, or I'm going to talk about, the research goals that I had for this project. Then we'll look at the demographics of the surveyed individuals that gave us our data. Then I will discuss briefly why I thought it was time for this research. Then we will look at what exactly SDN, software-defined networking, is. A lot of people on the phone today probably have their own definition. Everyone's got their own definition. There are a lot of definitions you can Google. I asked actual early adopters of SDN to tell me what they thought SDN was, since they're the ones using it, and I figured they would know best what SDN should be. Then we will look at the impacts on enterprise network management systems, first looking at the readiness of existing enterprise network management systems. Then we will look at the top new requirements for managing enterprise SDN, that is functional requirements for network management systems. Then we'll flip over to the communication service provider space and look at the readiness of their network management systems to handle SDN and network virtualization, and then look at some top requirements that they have for their management systems in the SDN world. Then we'll talk briefly about the path forward with management systems and SDN. We'll also look at a couple of organizational issues. The research we're discussing today looks at a lot of different organizational issues, such as top use cases, organizational drivers of SDN, organizational implementers of SDN. But I'm highlighting 2 organizational issues here in this webinar. One is the new skills that networking professionals are pursuing to implement and support SDN, and then overall business goals for SDN adoption. That is, we asked participants to identify the business goals that they hope to achieve through network transformation efforts around software-defined networking. So first of all, research goals. As I mentioned earlier, wanted to establish a definition of SDN. We wanted to assess the SDN readiness of existing network management systems and identify the new network management system requirements for SDN. We wanted to examine organizational impacts of software-defined networking implementation, explore use cases, benefits, business impacts, success levels of SDN. We then, to set the ground here, we assessed SDN along a variety of different categories. In the enterprise portion of the research, we looked at data center SDN underlays, that is, SDN in the data center in which network hardware is directly programmed in some way by a controller. That might be an OpenFlow solution or something like Cisco application-centric infrastructure. Then we looked at data center SDN overlays, which might be something like VMware NSX or Mida Cora or Nuage Networks or Juniper Contrail. Then we looked at campus SDN, which is a market that isn't as active as some of the others. Might be hard-pressed to name a solution, but I looked at it anyway. Software-defined WAN, which is its own little world, and then NFV, Network Functions Virtualization in the enterprise context. This is a term more commonly associated with service provider, but I think there's some room for looking at it as an SDN-related technology or use case in the context of this research. On the service provider side, software-defined networking and network functions virtualization were the two areas that we evaluated. So, research demographics, we surveyed 226 early adopters of software-defined networking. We defined those as organizations that have either started production SDN deployments or plan to do so within the next 12 months. All other individuals were discarded from the survey sample. Roughly speaking, 80 to 90, depending on which flavor of SDN we're talking about, between 80 and 90% of the research participants were actually in some stage of production deployment. Only a small minority were actually up to 12 months away from actually starting. 150 of the respondents to this research were enterprise IT professionals, roughly split evenly between management roles and staff roles. 76 were employees of a communication service provider who specifically identified themselves as someone who worked within the service provider network infrastructure organization. 46% from North America, a third from Europe, 20% from APAC. In the Asia-Pacific region, we surveyed individuals from companies headquartered in Japan and Australia. You see a wide distribution of company size here. We focused on companies with more than 250 global employees. Among the service providers in this response, they tended to be larger. A significant portion of them had 20,000 or more global employees. Why was it time for this research? Well, there's plenty of evidence that SDN's time has come. EMA research in 2014 found an 18% adoption rate that included organizations that had either started a deployment of SDN or had completed it. We will be refreshing those numbers in 2016. Cisco has claimed more than 1,000 customers of its ACI solution, which is not insignificant, and VMware claims 700 customers of its NSX solution. I read recently that AT&T serves millions of mobile subscribers over an SDN network, which is significant. Many organizations that are trying to lead the industry towards SDN, like Google, Microsoft, and many others, have shared details of production SDN use cases in data centers and wide area networks. So I think that the adoption is clearly happening. I think it'll pick up in 2016 and beyond. But one other reason why I did this research was that the SDN conversation tends to focus on architecture and use cases and less so on how organizations will operationalize SDN, how they will plan SDN, how will they support it with their existing management tools. So that was the goal of this research. So we asked early adopters of SDN to highlight the defining characteristics of SDN solutions that they actually implemented. That is, when you look at the SDN solution you implemented, what do you think are the defining characteristics of that solution that makes it SDN? And here are the top three: centralized controller, no surprise, low-cost hardware, and fluid network architecture. Fluid network architecture is open to interpretation, but I think of it, and I hope that some of the respondents thought of it as a network architecture that is open to change, open to programmability, not necessarily fixed and locked into a single vendor. But it can mean a lot of different things, but it was an option that they clearly gravitated towards. The least important elements of an SDN solution for these early adopters: number one, decoupled control plane and data plane. Now, that might fly in the face of the concept of a centralized controller at number one, but I think what's happening here is that enterprises and service providers see the value of a centralized controller. They want a controller that serves as a central point of programmability and control and visibility into their network, but they don't necessarily care how much of the actual control plane is decoupled from the data plane devices and consolidated in that controller. That is something that they don't necessarily need to know as long as the SDN solution is working and they're happy with it. And this kind of points to the fact that decoupling is not essential. Intent-based networking was also low on the second lowest priority. That's kind of new to the industry. It's kind of emerged on the scene. There's a lot of research and early solutions that looked at how something like application intent could control networks, but it wasn't until Cisco ACI came along that there was a very significant commercial solution on the market that was driving it. I think that might become more important depending on how customers of early intent-based networking solutions succeed and grow those types of solutions in their environment. Enterprises emphasized the centralized controller and fluid network architecture as the highest. Low-cost hardware was less of an important issue for them, whereas service providers considered low-cost hardware the most important issue above a controller. That's probably an indication that a lot of SDN implementations involve a lot of network functions virtualization implementations, and when you start doing NFV in a service provider network, a lot of that specialized, expensive hardware appliances like the evolved packet core and so forth get removed and replaced by software services deployed on off-the-shelf hardware. And abstraction of physical and virtual network elements was also a top issue for service providers when they were defining SDN. We asked enterprises, not service providers, just enterprises, to define software-defined WANs separately because I think it's pretty clear to the industry this is a different animal. It's an overlay in some respects. In some respects, it might be a solution that's based on legacy technology that's had some enhancements to it. It depends on which vendor you're talking to. But we asked enterprise adopters of software-defined WAN, only those who are actually adopting it, to pick out the defining characteristics for them. Number one on their list, cloud-based network and security services. They want to be able to consume some of these services that might have been deployed locally in their remote sites or maybe in the data center. They want to consume those in the cloud. Number two, centrally programmable network, which is analogous to the central controller in the general SDN definition. And then number three, hybrid WAN transport, which involves the virtualization of different network connections. For instance, a remote site might have a MPLS connection and also a broadband internet connection for backup or direct internet access. They want to be able to create pools of network resources that can be consumed by applications depending on things like policy and so forth and network conditions. And then we didn't ask our respondents to define this, but just definition here in the enterprise use case, just for the sake of discussing this, since I'm looking at it in the enterprise and not just the service provider space, NFV is a use case of SDN or related technology, depending on who you're talking to. It's a systematic virtualization of network functions traditionally delivered in hardware appliances. It requires new management and orchestration frameworks, and I believe it's applicable to both service providers and enterprises. The architectures of such solutions or concepts will be probably remarkably different depending on if it's a service provider or an enterprise, but I think it's worth discussing them in both contexts. So what about readiness of existing network management systems in the enterprise environment for SDN? Well, here we look at the two flavors of data center SDN, underlays and overlays. And you'll see these are enterprises who felt their existing management systems across planning and engineering tools, availability monitoring, performance monitoring, and troubleshooting, how ready those existing tools were to fully support SDN environments in the data center. And you see clearly the majority of early adopters of SDN feel that their tools are not ready to support data center SDN. The underlay appears more disruptive to existing management tools than the data center overlay technology. The overlay is more disruptive than the underlay, probably because overlays represent a new layer of software infrastructure on top of existing network hardware. A lot of enterprises suddenly have to correlate and visibility and troubleshooting processes across those two, engineering across those two. A lot of pre-existing incumbent network management systems might have been developed for hardware-centric infrastructure, and suddenly you have a software layer that you're responsible for. So that explains why they are perceiving overlays as more disruptive. So, other flavors of SDN in the enterprise space. All SDN technologies are presenting problems here. You see these, again, just small minorities of early adopters feel that their various management tools are ready to support campus SDN, software-defined WAN, and enterprise NFV. Campus SDN is clearly the biggest disruptor of all among types of SDN. I think that is probably reflective of the fact that it's just the least mature segment of the SDN market. There's just a lot of solutions out there. There's a lot of campus switches that support OpenFlow, for instance, but not a lot of OpenFlow controllers that have been optimized for campus use cases. You don't see a lot of applications developed for SDN controllers specific to campus use cases. I think that's an area of the market that needs some help. And we found more than 100 early adopters of campus SDN for this research study, and they clearly have needs that both the SDN solution vendors and the network management vendors need to address. In terms of new requirements for managing enterprise SDN, here are the top ones for planning and engineering and availability monitoring. Here you see the number one new requirement for planning and engineering tools is network state analytics and simulation. Basically, SDN introduces a lot of dynamism, a lot of change to networks. When they become more programmable, you need better visibility into how a network's going to behave based on how you configure it, what you add to it, what kind of applications you run on it. And here you're seeing an indication that enterprises want capabilities within their tools to analyze and simulate how network state is going to be affected by change, by adding new flows, etc. Speaking of flows, number two requirement is capacity planning based on SDN flows. And then number three was integration of DDI tools with SDN controllers, that being DNS, DHCP, and IP address management. That was only a priority for mid-size and large enterprises. Small companies were not interested in that, probably because they don't use commercial tools for those types of management functions. Availability monitoring requirements, number one, device metrics from compute resources that host virtual network elements, and number two, device metrics from those virtual network elements. There's a lot of abstraction in SDN, a lot of solutions that introduce virtual network elements, and you need to be able to monitor the health and availability of both the hosts of those elements and the actual software constructs themselves, and correlate across them and correlate from them to the hardware. And clearly, these early adopters of SDN have recognized the need for improved functionality around these capabilities. A lot of management vendors in the network space have introduced in recent years the ability to monitor virtual infrastructure, but I think there's a lot of maturing that needs to happen. Number three, device metrics from SDN controllers. SDN controllers are obviously a new element on the network, a very important element in most infrastructure architectures. So they've recognized that their availability monitoring tools need to be able to pull, model, monitor those new parts of the network. Enterprise requirements for performance monitoring and troubleshooting. We see number one for performance monitoring is the ability to understand and adjust monitoring of on-demand capacity changes. As I mentioned earlier, SDN creates a lot of dynamic change in networks. You might, in a lot of performance monitoring solutions are kind of static. They are set up by engineers to monitor strategic points on the network, maybe a core router. They set up a core router to send net flow records to a flow analyzer. They might tap strategic parts of the network where a lot of application flows traverse for packet analysis. When dynamic change comes, where a controller can programmatically add capacity here and there, places that were once critical points on the network where the most applications traversed are no longer the case. They might suddenly be elsewhere, or maybe another equally important part of the network needs to be monitored. So performance monitoring solutions need to track what those changes are and adjust their monitoring of them as such. Number two requirement for performance monitoring is network path visualization. This is not necessarily a new capability, but it becomes more important, especially with lots of virtual elements in the network now. You might have a traffic flowing across multiple elements on a single hypervisor host before it ever hits a physical switch, and you want to be able to visualize that entire path. It might be going through some sort of service chain on that host, like hitting a firewall and a load balancer and another application service workload before it finally exits the host and hits a physical switch. And you need to be able to see all that when you're trying to maintain end-to-end visibility into how each element of that chain, that service chain is performing. Troubleshooting requirements. Number one, they want reports on SDN flow activity. So you want to be able to look at each individual SDN flow and see how it's performing and be able to troubleshoot on that flow itself, abstracted from the actual physical or virtual network. They want to be able to look at that flow in isolation and troubleshoot on it. Number two, they want analysis of connectivity between controllers and SDN switches. Now, a lot of SDN solutions, when the SDN switches lose connectivity with that controller, they'll continue forwarding traffic, in some cases indefinitely, but those controllers add value to those switches. Either they tell it what to do with new traffic, or they create optimized paths for that traffic that the switches learn from the controller. So if the controller goes down or loses connectivity to that switch is going to still perform pretty well until it gets too many new flows or things it doesn't recognize, and it might start dropping. Depending on the architecture, it might start dropping traffic, or it might just doing best effort instead of optimized flows, and you'll start seeing some degradation in performance. And if you have an analysis of controller connectivity with those switches, you might be able to identify or eliminate that as a source of trouble rather quickly. Finally, reports on how network conditions affect SDN flows. It's kind of the reverse direction of the number one on reports of SDN flow activity. They want to be able to see how overall network conditions are affecting all their flows, and if they see, for instance, a switch that's congested or has a bad interface, they can identify all the flows that are being affected by it and move them or send them elsewhere and solve the problem quickly. Moving on to service provider network management readiness. We looked at three general categories of service provider network system management systems. Service provisioning and activation, which you see is also an individual network tool here. Then operation support and readiness tools, which includes change management, capacity management, and inventory management. And then service assurance tools, which includes performance management, fault management, SLA, OLA management, and end-to-end service management. And we asked them to assess each of these tool categories for their readiness to fully support SDN and NFV, and here you see those that say they do. These are the ones that say that their tools fully support SDN and NFV, and you see really low numbers. The biggest problem areas are end-to-end service management, change management, and capacity management, but really The majority of service providers across the spectrum are having trouble here. In terms of new requirements for managing service provider SDN in NFV, in the service provisioning and activation space, end-to-end management across physical and virtual network elements is very important. The most important next policy specification based on modeling of network configuration and operational state, and then service activation based on modeling of network configuration and operational state. Basically, these organizations, these communication service providers, want to be able to predict how the network is going to work, and they want to be able to plan for how the network is going to behave based on advanced modeling of network configuration data and operational state. This is going to be very important in terms of rapid provisioning of new services and monetizing your network. It's very difficult in a decentralized traditional legacy network to model network state, but in these SDN environments, they're anticipating that their management vendors will be able to extract and model networks. The network based on the telemetry and the information they're gathering from technology such as the switches and routers and the controller, and to be able to make their entire service provisioning and activation process more automated. This will also help them respond quickly to change if they can sort of simulate how new services or changes in how the network is behaving will affect overall policy execution and service activation. This kind of streamlines the process of adding new services and responding to problems. In terms of operation support and readiness tools, number one new requirement is software-based implementation of approved network and service changes. And second is inventory management of virtual network functions and virtual networks. Software-based implementation of approved network and service changes, it's simply getting the CLI out of the way, being able to implement changes without a lot of truck rolls, introducing a lot of automation to these processes. Inventory management of virtual network functions and virtual networks. It reflects the fact that a lot of these tools are set up as hardware inventory management systems that are reliant on a very static hardware environment. When you introduce a lot of virtual elements that are more mobile and moving around a lot across a very large communication service provider network, managing that inventory, maybe not necessarily more difficult, but just needs to be approached in a different way. You can't really rely on geography to tell you where your equipment is anymore. Service assurance tools, number one requirement there is end-to-end service quality across physical and virtual resources. I think this is pretty self-evident that that's a pretty important requirement to be able to sort of correlate how the physical and the virtual networks are performing and being able to identify how the two work together to deliver services. Bidirectional integration with SDN controllers, also a big issue. That means they want to be able to pull information from that controller about the overall network, and they want to also be able to push changes to those controllers from the service assurance tools. If a service assurance tool detects a problem, they want to be able to remediate the problem from that tool, and then it follows from there. Increased automation of network optimization. They want to automate the process of actually optimizing the network. Not doing a lot of manual change, but actually using the programmability of SDN to optimize the network. They want their service assurance tools integrated into that SDN infrastructure in a way that any optimization efforts they make through their service assurance systems can be done automatically in a closed-loop operation. So what's the path forward for management systems? Well, both enterprises and service providers are split on how to address the gaps in SDN readiness that we've identified here. When we ask them to tell us whether their management systems would fully support the various types of SDN that they're using. We gave them several options as an answer. First, they could say, our tools fully support this technology, and you saw the percentages earlier. Then they were able. Their other options for answers were modify existing tools, use new tools separately for SDN, use a combination of new and existing tools, and finally, don't know. Which, given the fact that we were surveying organizations that have already started, for the most part, their production deployments of SDN, the fact that any of them said don't know is kind of alarming, and we did see some high rates among different tools, depending on which tool type and which technology we were assessing, as high as 10 or 12% of organizations or early adopters of the technology still didn't know if a certain management tool would fully support their SDN implementation, which is, and in some cases that uncertainty actually rose depending on how far along they were in their production deployment, where because we asked those organizations what percentage of their production deployment was complete, and in some cases, particularly in the service provider space, that went up. That percentage of those who said they didn't know went up as they gained as they moved further along in the production deployment. Very concerning, but for the most part, that was a small minority of them. The rest were either said they're modifying their existing tools, using new tools, or using a combination of new and old, and they were pretty split across each tool type, across each technology. There wasn't a real consensus on what they're going to do about these gaps. And that kind of indicates to me that they're using different SDN technologies. They all have different solution providers in the SDN space, and all those solutions have varying capabilities around the native manageability of the architecture that they're installing. And that has some bearing on whether or not their existing management tools will be able to fully support this stuff. Another variable that's probably influencing this sort of lack of consensus on what to do is the roadmaps of their network management providers. I've talked to many network management vendors who have a lot of details in their roadmap for SDN support. I've talked to others who don't really know yet, and I've talked to a few others who don't really believe SDN is going to happen anytime soon, and so they don't really need to have a story around it. That indicates to me that depending on what your incumbent management vendor is, you have a very different opinion on whether or not that management tool is going to be able to support your SDN solution. So what should you do? Well, you got to assess the manageability of whatever SDN solution you are thinking of using. They all have very different capabilities. I've seen a lot of 1.5 and 2.0 releases coming out with management features that are clearly responses to requests from early adopters who've said we can't manage this the way you've brought to market. And you need to ask those SDN vendors whether they're partnering with management vendors. A lot of SDN vendors have partnered with Layer 4 through 7 services vendors and security vendors for implementing those third-party network services into their architecture, but you're starting to see some of them partner with management vendors too, and I think that's going to be very important moving forward. And clearly, you need to ask your network management vendors what their SDN roadmap is. Is your incumbent vendor addressing the new functional requirements identified in this research, the ones that are on the slides before, but also if you download the research, you're going to see a lot more data on other requirements. You should really think about which requirements are going to be important to you and drill your vendors on whether or not they're going to address them. And can you complement your management systems with a new tool? There are a lot of management tools emerging right now that are really kind of specialists in providing like new ways of visualizing SDN or looking or identifying end-to-end visibility across physical and virtual elements. You might want to see whether those tools can sort of complement what you have right now, and whether those tools have APIs and partnerships in place to work with your incumbent vendors. You might be able to cobble together a solution that works for you. Okay, so looking at some organizational impacts, I'm kind of running along here, so I'm going to whip through these. SDN skills for networking professionals. A lot of people have been wondering for a couple years now, am I going to have to become a programmer? And in the enterprise, the top 4 priorities here, you see cloud management systems is at the top, which kind of clues you into the fact that SDN is really supporting cloud implementations in enterprises. They're learning how to use OpenStack as network engineers. Clearly, the SDN combines with cloud, private and hybrid cloud environments. They're learning new network protocols, whether that's something like OpenFlow or something like VXLAN. That's their number 2 priority. And then number 3 and 4 for enterprise networking pros, programming skills, very specifically not scripting skills, and that's formal programming skills, and then software development skills. In the communication service provider space, same list of priorities, but a different order. Software development and programming skills are the top 2 skill requirements in the service provider space, and then cloud management systems and new network protocol knowledge are 3 and 4. So clearly, there's a lot more use of APIs and open source technology and homegrown SDN applications going on in the service provider space, but in the enterprise space too, the networking professionals are learning how to work with and develop software and work with APIs. A lot of SDN vendors provide open APIs. A lot of ecosystem vendors that work with SDN solutions are providing open APIs, and clearly a lot of enterprises are going to be working directly with those APIs in the future. Lowest priorities for skills, DevOps automation tools, and certifications. We asked them separately about vendor-specific certifications and general industry, vendor-neutral certifications. Very low priority, both of those. I think the SDN certification market is kind of immature at the moment, so maybe in future versions of this research we'll see that rise as more certifications reach the market and spend some time, and network engineers spend some time ascertaining the value of them. Finally, we're going to look at business goals. The question was, what business outcomes do you hope to achieve based on your network transformation efforts around SDN? We asked both enterprises and service providers this question. Among enterprises, biggest issue that they hope to, well, the biggest business outcome they hope to achieve is improved end-user productivity, followed by revenue growth, and then improved customer brand loyalty and retention. You see at the bottom, reduced expenses and costs is the lowest priority for everyone across enterprises and service providers. Kind of a surprise since, commoditization of network hardware was on everyone's minds when SDN first came along. And even in the definition of SDN, low-cost hardware is a defining characteristic of it. But in terms of business outcomes, they don't see SDN as driving down costs for an enterprise. That's not. I think only about 3 or 4%, if memory serves, saw that as their top priority for business outcomes. And then in the service provider space, also improved end-user productivity was the top one. That's probably applies to both internal employees of the service provider and also end customers. Revenue growth, again, number 2. And then number 3 for them was operational trust, which most of you are probably familiar with, but it's a term from military parlance. It's just the assumption that the people at the top of an organizational flow chart can dictate certain things to happen in battle or in an enterprise, and they can operate under the assumption that their orders will be executed by individual units underneath them to achieve an overall goal. So in the service provider space, that's the number 3 business goal. They want more operational trust as a result of the implementation of SDN. They want a business leader or CTO to be able to say, we want to do this with our network, and then it gets done. And they think SDN is going to be able to help them do that. So in conclusion, in terms of impacts of SDN on network management, early SDN adopters value a centralized controller and low-cost hardware. They have determined their existing network management systems are not ready for SDN. They've identified some concrete capabilities they need in those tools in order to make them capable of supporting SDN. And networking organizations need to have a manageability discussion with SDN solution providers and management vendors. Networking pros are indeed learning programming and software development skills. And early adopters say SDN is going to boost productivity and grow revenue, and they don't really necessarily care that much whether it reduces costs. All this and much, much more is available in the research report, Managing Tomorrow's Networks, which can be downloaded from our website, which you will get a link to in the follow-up email. And with that, I'll turn it over to Raleigh for the Q&A phase.
Thank you, Shamus. We are running a little bit over, so I'm just going to I'll give you one question, Shamus. For those of you who asked questions, if we didn't have an opportunity to get to it here, I will send them on to Shamus. Shamus, one question that we received is, what is a fluid network architecture and why is it important?
I guess I should have defined that more. Okay, so fluid network architecture. I didn't write down a definition for myself when I put that in the questionnaire, but really, if you think about pre-SDN networks, they're very static in a decentralized control plane that legacy networking is characterized by today. When you need to make a significant change to the network, in many cases you're going to be going into individual nodes on the network and making changes in CLI. You may have some scripting in place to speed that up. You may have some management systems that can consolidate some of that. But for the most part, when you're, for instance, adding a new remote site to your wide area network, or you're adding a new application to your data center, there's a lot of work that needs to go on for weeks, months on the network to make sure that that the execution of that implementation goes off without a hitch. And even then, you're going to have a lot of bugs that emerge from the dark shadows of your infrastructure that you have to stamp out with a hammer or fly swatter. With a fluid network architecture, you have a network that's sort of adaptive to change. And you add a new application, you don't have to start from scratch and be like, what's my capacity? Oh, I need to get some spreadsheets out. I need to talk to whoever installed the switch 10 years ago. You have a network that is that responds to change perhaps programmatically or through some sort of architecture that you've implemented in software that abstracts the hardware, abstracts network services away from the hardware, so the hardware only has to worry about IP forwarding and doesn't have to think about what the IP addresses or that the IP addresses of different applications are moving around a lot. You have a network that just responds to change, you can add capacity based on network flows. You don't have to think about things. You don't have to think about individual switches. You think about your network as one big resource. And I think that's my babbling way of describing fluid network architecture. But I'd be welcome to discuss it with anyone over email or over the phone if you want to reach out to me at a later time, and we can hash out a definition more clearly. But I think that's all I have to say on the matter.
Great. Thank you for that clarification, Shamus. And as I mentioned earlier, I will send any unanswered questions to Shamus. We appreciate all of you attending and asking those questions, too. I do hope that you'll check out that email that is being sent by EMA tomorrow. It will include the on-demand playback and a link to the report. Thank you all for joining us, and enjoy the rest of your day.